Let's do this problem as a little bit of a warm-up and as a introduction to another topic. Well, it's not really an introduction, I did speak about it. However, if I have 40 liters of nitrogen, notice I have nitrogen plus hydrogen yields ammonia. Notice that this is a G, that means gaseous state, gaseous state, gaseous state. The state of the chemical that's taking part in the reaction is always in parentheses following the formula. So I have 40 liters. I want to do the volume of each of these, how many moles of each of these, and the mass of each of these. Correct? Yes? What's the very first thing you want to do? Every time you do a volume, mass, volume, volume, mass, what's the very first thing you want to do? The very first thing you want to do?
Find the mole.
You want to find the moles. But before we even find the moles, yes, very good, Portia, you want to find the moles. Let's put up here the stoichiometric masses. This is going to be 28, 6, 34. And then you want to find the moles. That was the correct answer I was looking for. Find the moles. Always do moles. Everything comes from moles. All roads lead to moles. And all roads lead from moles. So, if I have 40 liters of nitrogen gas, how many moles is that? Remember, a liter is the same thing as a cubic decimeter, right? What the IB says, a cubic decimeter, okay? So it's 40 cubic decimeters. 40 cubic decimeters. So how many moles is 40 cubic decimeters? What would you divide it by? In other words, volume, if you're going to express volume, how do you say moles in volume? 22.4. I'm going to speak volume, okay? The translation for 22.4 is mole, okay? That's how you speak. That's the translation. If you want to speak, you want to say moles but use volume, you say 22.4 liters, right? Yes, Portia.
But the IB said it's 22.7.
You do what the IB says, but I'm using 22.4. It's just my own habit.
Wait, where does it say 0.7? Data.
In the data book, it says 22.7.
Yeah.
What are the conditions?
Molar volume of an ideal gas at STP is equal to 22.7.
I've always used 22.4, but give to IB what is IB's, but give to me what is me, okay?
What about the test?
Do 22.7 for all, you got to do what you got to do. Okay, the whole world, whatever. Okay, but thank you, Portia. All right, so you're going to divide it by 22.4. So what's 40 divided by 22.4?
1.79.
1.79? Okay, good. 3 Simeon figures, that's plenty. 1.79, okay. And then how many moles would this be? This is 1 mole, 1 to 3, right? So what would 1.79 be relative to this?
5.36.
5.36? Yeah, because it's just 3 times this, right? It's just a mole ratio, isn't it? Right? So what would this be?
3.58.
What is it?
3.58.
3.58? Good. Now just multiply this by what to get this? 22.4. Easy. So what's that times 22.4?
120.
What is it?
120.
120? Good. What's this? What is it?
80.
280?
No, 80.
200,
Oh, yeah,
208?
80. 80. 80.
80?
Yeah,
280.
just 80.
80.
Because
Okay, sorry, Portia. Okay, so then how many mole, what's the mass of this going to be? In other words, what's the mass of 1 mole?
14.
No,
28.
28, right? So the mass of 1 mole, what's the mass of what times 1 mole?
15.1.
So 28 times 1.79 is 15?
15.
50.1. 50.1, okay? And that's grams, of course, okay? Grams, mole, liters. All right, so then what's 5.36? What's the mass of 1 mole of hydrogen?
6.
No.
Oh no, it's 2, isn't it?
Yeah, you gotta know what they're asking for. They're not asking for 3 moles, they're asking for 2 moles. They're asking for 5.36 moles. So what's 5.36 times 2? 10 point something. 10.6?
7.
10.7? And what's 3.58 times what? 17, good.
16.9.
What is it?
16.9.
16.9 grams. Is that right?
16.
60. Okay, sorry. My hearing's not good this morning. 60.9?
Yeah.
Is that right? Okay, good. And then, now, excuse me. Woo! Now, can I erase this? Is that okay? Can I erase that? Okay? Right, now. Let's say I'm given 48 grams of this and 36 grams of that. Okay? Which one is going to be the limiting reagent? Which one's going to be the limiting reagent? You could do it several ways, right? You could do it several ways. How do you do it by just inspection? Can you do it by inspection?
Is this what you guys talked about when I was gone last Friday?
No.
No, I spoke about it very briefly. But can't you do this by inspection? In other words, if you have 28 grams of this, you need less than 1/4 of this, don't you? Yes? But if you have 6 grams of this, you need 4 times that amount, right? Do I have 4 times 36 grams?
No.
No, I don't. So what's going to limit the reaction? Do I have enough of this to react with this? Or do I have enough of this to react with this? Which one's going to limit the reaction?
48 grams.
What is it?
The 48 grams.
Yeah, because the 48 grams, how much do I need? Less than 1/4. Less than 9 grams. Do I have 9 grams?
Yeah.
I don't. Do I have at least 9 grams here? Yeah. If I have 36 grams, I'm going to need like almost 200 grams. Or probably more than 200 grams, right? Do I have that?
No.
No. So what's going to limit the reaction?
48. And then
This is going to limit the reaction. That's the limiting reagent. Okay? So you can do this by inspection. It would make sense. And the IB may do that. They may say, instead of you going through all of these calculations, say, okay, fine. Can you just simply do it by inspection? But let's just do a simple calculation to see. Pick one. And then If one turns out to be excess or limiting, then the other one is the opposite. Okay? So let's pick 36. Let's just pick it. Okay? And see if we have enough here. So this is going to be 36. We'll say this is 36. And we'll say this is x. Okay? So I'm comparing these two. So I'm comparing nitrogen with hydrogen, which is 28 over 6, and then x over 36. Do that math. What do you get?
168.
138, what is it?
168.
168. Okay, so you don't need 200 grams, but you need 168 grams, correct? Okay, so do I have 168 grams? Do I have 168 grams? Therefore, what's limiting? According to the simple calculation.
The nitrogen.
Yeah, this is limiting, and this is excess. You're done. Now, come up with this value here. Now come up with this value. How much ammonia is going to be produced? How much? How much ammonia is going to be produced? So we're going to say 2 NH3 over 2 NH3 over, this is limiting, so N2 equals 34 over 28 equals 48 over X over question mark. What's it going to be? What is it?
39.5.
39.5? Okay, so this is 39.5 grams. Good. Excellent. Excellent. So we can say 39 point, so this is going to be 48. And this will be 39.5. Okay. Now, how much of this are you going to have left over? How much of that are you going to have left over? Shall we do that? So if you say, if I burn all this, how much of this will I burn? So I'm going to compare nitrogen to hydrogen, and then I'm going to say 28 over 6. And then
Oh, Mr. T.
48,
Mr. T.
yes.
I think you made a mistake. For the
Did I make a mistake?
Yeah, like 48 should be
On the bottom.
Yeah, on
Yeah.
Excellent catch. Excellent. Well done, Portia. I made a mistake. So I'm going to say 48 is here and X is here, right? Excellent catch. Well done. We're glad we caught that on the film, right? Excellent. Well done. You'll never know if I did that on purpose. So what do you got? 34 times 48 divided by 28.
58.3.
58.3 grams. Okay? Why does that make more sense?
Because it's more than.
I kind of let it go because, yeah, see, 34 it's got to be a little bit more than the 28, right? It's got to be a little bit more. So that makes a lot more sense. But I let it go in hopes that I would not have turned the film off without it. Okay. So now what? What's excess? What am I comparing?
Hydrogen and nitrogen.
Hydrogen and nitrogen. And that's going to be 28 over 6, 48 over, we'll call it y. You know what? We'll just call it e. We'll call it excess. Okay? And this is going to be 58.3. Is that coming up on here, huh? Is that coming up on the thing?
Yeah, that line is right about where the thing ends.
Excellent.
It's like a little bit more space, but. Yeah.
Thank you. So what do you got? Is this right?
Yeah.
Your answers always have to make sense. You know, they should make sense, yeah? So what do you got?
10.3.
What is it? 10.3?
Yeah.
10.3 grams? Right? Right? So how much am I going to have in excess?
10.3.
How much?
10.3.
No, that's how much I'm going to actually burn, Lauren, right?
Oh.
If I burn 48, I've got to burn 10.3. Isn't that what that says?
That makes a lot of sense.
Make sense? Okay. So what is 36 from 10.3?
25.7.
What is it?
25.
I can't hear you.
25.7.
25.7. That's how much is left over. Yes? Okay, now let's do this. So far, so good. So far, so good? All right. All right. How many moles of this reagent did I burn? How many moles? 48, it was 48 grams. How many moles is that?
2.14.
2.14. Right? 2.14 moles. Okay? Right? Yes? How much of this, therefore, did I burn? If you want to do it this way, 10.3, 3 to 2, 3 to 1, sorry. So how much did I do?
6.42.
What is it?
6.42.
6.42.
42.
Good. And how about this?
4.28.
Good. That's how many moles of each, right? Yes? Okay, now, let's say I have a closed container.
Wait, Mr. P.
Yes,
I think I made a mistake.
you made a mistake?
Yeah.
What'd you say?
The grams, that's actually grams, but I thought it's like volume.
10.3 grams is how many moles? So it'd be 3 times that, right? So that's right, 6.42, right? That's how many moles, right?
No, I mean, I was wrong from the beginning. Like the 2.14 moles is wrong. Because it's gram.
Grams, right? So 48 divided by 28 is not 2.14.
Yeah.
That's all right.
That's 1.71.
What is it?
1.7.
Okay, what is it?
1.7.
1 point, yeah, maybe that doesn't make any sense, right? So 1 point what?
71.
1.71, and this is what?
5.13.
5.13, and this is what? 3.42, is that right? Do we have any verification on that? Professor Munkel, are you back there verifying these answers or playing Angry Birds or something?
Maybe both.
Maybe both. Okay, good. Excellent. Lauren, you going to help us verify?
No calculator, like I have.
No. Oh, the old I don't have a calculator excuse.
I mean, I could go get a pocket calculator for my purse, but it is 10.
You may borrow them.
Thank you. But
All right.
personally, I think it is true because the mass is very similar to the original mass that we had, and
Yes.
therefore the answers are also very similar to the original mass.
Yes. That's, I understand. It's still a week back. It's only our second class since our vacation. So we're all a bit rusty. But I have no problem making mistakes on the film as long as we catch them on the film. You know? It shows what a class is really like. No class runs perfectly, especially mine. Are your other teachers perfect at everything they say?
No.
No. Okay. Especially that Mr. Jeff, huh? Okay. All right, now, so let's say we have a 40-liter container, okay? What's going to be the pressure? What's going to be the pressure? Are these right now, Portia? Are these correct? These moles? They are, okay? So now let's say I have a 40-liter container. What's going to be the pressure? What equation would I use? How would I do that? And we'll say an STP. We'll say an STP, right?
STP is 273K and 100 kPa.
Okay. But what equation would I use?
The boys law.
What is it?
Boys law. The P1, V1 equal to P2.
No.
We would work backwards from the ideal volume of molar gas. That's very similar to what Porcelain just did.
Yeah, similar. But we're not comparing the before pressure. Okay, what's the pressure now? What's the pressure now?
100 kilo.
No.
273K.
Well, what's the volume going to be? What's the volume going to be? 40 liters, right? Or 40 cubic decimeters, right? We don't know the pressure. What's R going to be? What's R say in your book? What's R?
Gas constant.
Yeah, and what? Yes, thank you. It's the gas constant, but what's the value?
8.31 JK minus
8.31 J. Good morning. 8.31 J.
K minus 1.
JK minus 1,
And then mole minus 1.
and then mole minus 1,
Yeah.
right? Okay. They love to use those negative exponents, the IB. I personally hate them. But that's okay. All right, so what's the temperature? What's the temperature?
270.
Okay. What's the number of moles? What's the number of moles?
1.7.
Add them up. 1.71 plus what? Come on, guys. 5.13 plus what? 3.42, right? What's that equal?
10.26.
What is it?
10.26.
10 point I can't hear you. You're 20.26?
10.2.
10.26. Okay, is that correct? Is that correct? Remember that problem I did maybe the second week of school? That really hard stoichiometric problem I did? Do you remember many moons ago? Do you remember?
It might have been the grade 12s because you didn't let us do stoichiometry.
Maybe it was the grade 12s. Okay, fine. You're right. Maybe it was the grade 12s. However, isn't there excess ammonia in there? I mean, sorry, isn't there excess hydrogen in there?
Yes?
How much excess?
25.7.
Isn't that grams, right?
Yes.
Isn't that going to contribute to the pressure? According to Dalton's laws of partial pressure, isn't that going to contribute to the pressure? Isn't it? You may want to write that down. You want to read up on Dalton's laws of partial pressure. Very simple, guys. Very simple. You may want to review that. And we'll talk about it, if you remind me. It's very simple. Very simple. Okay, so how many moles of excess am I going to have? So 25.7 grams of hydrogen. How many moles is that?
.13.
Does that make sense to you?
Yes?
It does. What's the mass of 1 mole of hydrogen?
20.
2, right?
Yeah.
So 25.7 grams divided by 2.
Oh, no, I divided it by the thing jig with, yeah.
Not a problem. Measure twice, cut once. Calculate twice, think 3 times.
12.85.
12.85? All right. And what's that going to be? What's 10.26 plus 12.85?
23.11.
23 point what?
11.
23.11? Are we okay with that? Yes? Now, so I want to say, can I erase this 40? So I want to say P equals nRT over V. So let's put it in, okay? P equals N, which is 23.11. We'll leave off the unit labels. Just looks neater. I know, many chemistry teachers are probably aghast that I said that. No, not that! And then T is 273. And then what?
Volume is 40?
What is it?
Volume is 40.
Volume is 40. So what's P?
Oh,
1,310.7.
1,310.7.
0.7.
What?
Oh, it just goes 700,983, so I'm just gonna discount the rest of that.
Is it done?
I got low battery.
What does it say?
Yeah, I got.
Low battery?
Yeah.
Okay. Thanks, hon. So what does it say? Is it pascals or torrs or what? What is it?
I got 131.05.
23 times 8.31 times 273 divided by 40. Could we try that again, guys?
Lawrence.
Lauren's right.
I'll do that.
Eden's a little sleepy. That's okay. That's all right. You look exactly like we all feel.
Oh, that's not good.
No, you just look sleepy, that's all. What is it?
Pascal.
Pascal's. Okay? Easy? Don't forget the excess. Big, 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 big. Okay? Don't forget the excess. All right? All right. Are we off?